Hello, welcome back. Welcome back. I'm John, an old YouTuber. So let's continue. I was watching the news in Danish news 12 noon, but now it's 1 p.m. But of course I did record a video. Then then I made another video. I was outside to get a small package of comics, like this one. That's 45 Danish kroner. That's like $8, but that's rating 9.4. Then maximum is 10. So that's like a brand new. That's from 1986. So that's the collectors, they like it in this quality. But that was the only one, because that was the number 100. That's the final one from 1986. I was 20 years old back then. So, but let's just continue. So this is voltage. And after voltage we do electricity. I have the electricity there. Yes, then I just like try to follow this long page. So this can take some many days, some weeks, but if you can spend many months to play some computer game, you can spend some months to do this, because actually I could learn something. But the problem is I cannot remember all this. But maybe a little bit I can remember. Yes, if I could remember all this, I would be very clever. But problem is I cannot do that. My brain is not like that. I cannot remember all this. Even I just read it, then I have to read it, 10 times, and probably I can still not remember. But some people can remember what they're reading. I cannot do that anymore. I will not remember all this. When I read this, you ask me what is voltage. I will probably not explain what it is.
Voltage. Voltage a 23 battery comparison 1.jpg. Batteries are sources of voltage in many electric circuits. Common symbols V, U, UZ unit volt in psi base units gem 2s3a1 derivations from the quantities voltage equals energy / charge a dimension L2T3I1. Voltage, electric potential difference. Electric pressure or electric tension is the difference in electric potential between two points, which, in a static electric field, is defined as the work needed per unit of charge to move a test charge between the two points. In the International System of Units, the derived unit for voltage, potential difference, is named volt. 166 in SI units. Work per unit charge is expressed as joules per coulomb, where 1 volt equals 1 joule of work per 1 coulomb of charge. The old SI definition for volt used power and current. Starting in 1990, the quantum Hall and Josephson effect were used, and recently, 2019, fundamental physical constants have been introduced for the definition of all SI units and derived units. 177F, 197F voltage or electric potential difference is denoted symbolically by simplified V2 or U3. For instance, in the context of Ohm's or Kirchhoff's circuit laws. Electric potential differences between points can be caused by the buildup of electric charge, for example, a capacitor, and from an electromotive force, for example, electromagnetic induction in generator inductors, and transformers. 5. On a macroscopic scale, a potential difference can be caused by electrochemical processes, for example, cells and batteries. The pressure-induced piezoelectric effect and the thermoelectric effect. A voltmeter can be used to measure the voltage, or potential difference, between 2 points in a system. Often a common reference potential such as the ground of the system is used as one of the points. A voltage can represent either a source of energy or the loss, dissipation, or storage of energy. Contents. Definition in electrostatics. Generalization to electrodynamics. Treatment in circuit theory. Volt. Hydraulic analogy. Applications: addition of voltages. Measuring instruments. Typical voltages. Galvanic potential versus electrochemical potential. History. See also. References. Footnotes. External links. Definition. There are multiple useful ways to define voltage, including the standard definition mentioned earlier. There are also other useful definitions of work per charge. See Galvanic potential versus electrochemical potential. Voltage is defined so that negatively charged objects are pulled towards higher voltages, while positively charged objects are pulled towards lower voltages. Therefore, the conventional current in a wire or resistor always flows from higher voltage to lower voltage. Historically, voltage has been referred to using terms like tension and pressure. Even today, the term tension is still used, for example within the phrase high tension, height, which is commonly used in thermionic valve, vacuum tube, based electronics. Definition in electrostatics. The electric field around the rod exerts a force on the charged pith ball. In an electroscope in electrostatics, the voltage increase from point to some point is given by the change in electrostatic potential from to. By definition, 678. This is in this case, the voltage increase from point A to point B is equal to work done per unit charge, against the electric field, to move F charge from A to B without causing any acceleration. 1991. Mathematically, this is expressed as the line integral of the electric field along that path. In electrostatics, this line integral is independent of the path taken. 91. Under this definition, any circuit where there are time-varying magnetic fields, such as AC circuits, will not have a well-defined voltage between nodes in the circuit, since the electric force is not a conservative force in those cases. Note 1. However, at lower frequencies when the electric and magnetic fields are not rapidly changing, then this can be neglected. See electrostatic approximation. Generalization to electrodynamics. In a static field, the work is independent of the path. The electric potential can be generalized to electrodynamics, so that differences in electric potential between points are well defined even in the presence of time-varying fields. However, unlike in electrostatics, the electric field can no longer be expressed only in terms of the electric potential. 417. Furthermore, the meaning and value of potential differences will depend on the choice of gauge. 419. 422. In this general case, some authors, 7, use the word voltage to refer to the line integral of the electric field, rather than to differences in electric potential. In this case, the voltage rise along some path from to is given by however. In this case the voltage between 2 points depends on the path taken. Treatment in circuit theory. In circuit analysis and electrical engineering, lumped element models are used to represent and analyze circuits. These elements are idealized and self-contained circuit elements used to model physical components. 8. When using a lumped element model, it is assumed that the effects of changing magnetic fields produced by the circuit are suitably contained to each element. 8. Under these assumptions, The electric field in their exterior to each component is conservative, and voltages between nodes in the circuit are well defined, where 8, as long as the path of integration does not pass through the inside of any component. The above is the same formula used in electrostatics. This integral, with the path of integration being along the test leads, is what a voltmeter will actually measure. 9. Note 2. If uncontained magnetic fields throughout the circuit are not negligible, then their effects can be modeled by adding mutual inductance elements. In the case of a physical inductor though, the ideal lumpy representation is often accurate. This is because the external fields of inductors are generally negligible, especially if the inductor has a closed magnetic path. If external fields are negligible, we find that is path independent, and there is a well-defined voltage across the inductor's terminals. 10. This is the reason that measurements with a voltmeter across an inductor are often reasonably independent of the placement of the test leads. Volt. The volt symbol, V, is the derived unit for electric potential difference, and electromotive force. The volt is named in honor of the Italian physicist Alessandro Volta, 1745-1827, who invented the voltaic pile, possibly the first chemical battery. Hydraulic analogy. A simple analogy for an electric circuit is water flowing in a closed circuit of pipework, driven by a mechanical pump. This can be called a water circuit. The potential difference between 2 points corresponds to the pressure difference between 2 points. If the pump creates a pressure difference between 2 points, then water flowing from one point to the other will be able to do work, such as driving the turbine. Similarly, work can be done by an electric current driven by the potential difference provided by a battery. For example, the voltage provided by a sufficiently charged automobile battery can push a large current through the windings of an automobile's starter motor. If the pump isn't working, it produces no pressure difference, and the turbine will not rotate. Likewise, if the automobile's battery is very weak or dead, or flat, then it will not turn the starter motor. The hydraulic analogy is a useful way of understanding many electrical concepts. In such a system, fuel done to move water is equal to the pressure drop, compare PD, multiplied by the volume of water moved. Similarly, in an electrical circuit, the work done to move electrons or other charge carriers is equal to electrical pressure difference multiplied by the quantity of electrical charges moved. In relation to flow, the larger the pressure difference between 2 points, potential difference or water pressure difference, the greater the flow between them, electric current or water flow. See electric power. Applications. Working on high voltage power lines, specifying a voltage measurement requires explicit or implicit specification of the points across which the voltage is measured. When using a voltmeter to measure potential difference, one electrical lead of the voltmeter must be connected to the first point, one to the second point. A common use of the term voltage is in describing the voltage dropped across an electrical device, such as a resistor. The voltage drop across the device can be understood as the difference between measurements at each terminal of the device with respect to a common reference point, or ground. The voltage drop is the difference between the two readings. Two points in an electric circuit that are connected by an ideal conductor without resistance and not within a changing magnetic field have a voltage of 0. Any 2 points with the same potential may be connected by a conductor and no current will flow between them. Addition of voltages. The voltage between A and C is the sum of the voltage between A and B and the voltage between B and C. The various voltages in a circuit can be computed using Kirchhoff's circuit laws. When talking about alternating current, AC, there is a difference between instantaneous voltage and average voltage. Instantaneous voltages can be added for direct current, DC, and AC, but average voltages can be meaningfully added only when they apply to signals that all have the same frequency and phase. Measuring instruments. Multimeter set to measure voltage instruments for measuring voltages include the voltmeter, the potentiometer, and the oscilloscope. Analog voltmeters, such as moving coil instruments, work by measuring the current through a fixed resistor, which, according to Ohm's law, is proportional to the voltage across the resistor. The potentiometer works by balancing the unknown voltage against a known voltage in a bridge circuit. The cathode ray oscilloscope works by amplifying the voltage and using it to deflect an electron beam from a straight path so that the deflection of the beam is proportional to the voltage. Typical voltages. A common voltage for flashlight batteries is 1.5 volts, DC. A common voltage for automobile batteries is 12 volts, DC. Common voltages supplied by power companies to consumers are 110 to 120 volts, AC, and 220 to 240 volts, AC. The voltage in electric power transmission lines used to distribute electricity from power stations can be several hundred times greater than consumer voltages, typically 110 to 1200 kV, AC. The voltage used in overhead lines to power railway locomotives is between 12 kV and 50 kV, AC, or between 0.75 kV and 3 kV, DC. Galvanic potential versus electrochemical potential. Inside a conductive material, the energy of an electron is affected not only by the average electric potential but also by the specific thermal and atomic environment that it is in. When a voltmeter is connected between two different types of metal, it measures not the electrostatic potential difference, but instead something else that is affected by thermodynamics. 11. The quantity measured by a voltmeter is the negative of the difference of the electrochemical potential of electrons, Fermi level, divided by the electron charge and commonly referred to as the voltage difference, while the pure unadjusted electrostatic potential, not measurable with a voltmeter, is sometimes called galvanic potential. The terms voltage and electric potential are ambiguous in that, in practice, they can refer to either of these in different contexts. History. The term electromotive force was first used by Volta in a letter to Giovanni Aldini in 1798, and first appeared in a published paper in 1801 in Annales de Chimie et de Physique. 12. 408 Volta meant by this a force that was not an electrostatic force, specifically, an electrochemical force. 12. 405 The term was taken up by Michael Faraday in connection with electromagnetic induction in the 1820s. However, a clear definition of voltage and method of measuring it had not been developed at this time. 13. 554 Volta distinguished electromotive force, EMF, from tension. Potential difference. The observed potential difference at the terminals of an electrochemical cell when it was open circuit must exactly balance the EMF of the cell so that no current flowed. 12. 405 See also. Electric shock. Mains electricity by country, list of countries with mains voltage and frequency. Open circuit voltage. Phantom voltage. References.
Yes, video stop. The video splits in less 1 minute, so let's keep it one part. This was last edit 14 July. Yes, I will upload this, but I will just continue. Next one is electricity. But I need something to drink, but the video splits in 20 seconds, but we can go to my kitchen. But that's like 50, that's a lot of PDF. Yes, but we are out of time, so I have to stop the video.